Today I'm going to talk about another topic that is quantum computing. This is a new era for me and it's a little bit difficult because it's not contains the basic quantum physics but also there are a lot of linear algebra, Heisenberg matrix and a a lot of computer science, algebra, algorithm, and some digital circuit design and so on. I think it's a really interesting thing for me to explore it. So here we go. The first chapter is mainly about the background and the basic knowledge about this topic. So here we go. There's Moore's law means that after 1.5 years, the efficiency of the chip will double. And now there is statistics of the performance, and so there is another topic about the path forward, that is the line. The vertical line is the new devices and the new materials, and the um, parallel line is the new architects and packings. And there are, it seems that two legs. The one is the physics of one is your physical body, and the one is your mind. So the combination is just important, and the future combination, I think, is about quantum, and quantum computing is another. I think it's just the intersection of these two legs. Okay, there are some development time from the more than 100 years, and there are we came to and the first computer ENIAC, and but in 1980s, the Richard Feynman proposed this concept, about quantum computing concept, and later, and with the development of our so I think there are many important time points that about the different or algorithm, different process. So here we just build a fundamental knowledge about networks, materials, and computing, simulation, cryptography, software, distribution, computing. Also, it's display it's just the intersection that combines all of them in computer science and security, now common sensors, materials, and so on. It's very complex. It's a lot of intersections of both engineering and mathematics, physics, and so on. Also, the IEEE standard association project that here is the display and commercial quantum processors, maybe the most famous in China. I think it's about in the Chinese in the technology university, and the other is about IBM, Google, and so on. I think Qutumn in China, and others like some I don't know their names, but I think IBM nowadays lead first. To realize the promise of quantum computing, we must engineer a system that is both robust, reproducible, and extensible. And so there are comparison between classic and quantum, that is the state and qubit and bit, and this is, I think, in the most different things are just bit and gate. Bit means bit, qubit, classical gate, and quantum gate. The bit, there are only two types in classical computer, but in quantum field there are the qubit means that there are different combinations. So the combination means the superposition states that a little linear algebra, and the computer relies on encoding and decoding. Encoding because of the basic element for qubit. So there are different encoding ways from the classic ones. And there are parallelism means what? the different representatives more information and paradigms interference, and what is different in quantum computing is what is the advantage of the quantum computing. The memory computing means in memory computing it holds information in form of quantum state, which is modified by applying an operation on them. I think it can run because it's a rejection from one state to one element. After a gate, we can get another state, so we can get more information about the operation. Also, there are some um, something that we need to do. That is the error correction. There's something that decoherence and so on, imperfect operations, and if we can protect it well, so the error must be less. So this is the Mabcom, also huge and so interesting and so much possibility for this field. And the one slide we can summarize the quantum computing, that is the advantage and the ugly. I think we can focus on the bad thing, that is extremely broken and also a limited application, because of it can only focus on the specific problem, like divided a very big number, but it cannot have many. It doesn't have many functions like classical ones. Also, the ugly and contemporary provide two PV because of the physical environment and physical technology. We can have more qubits in one machine now. So this is the process we are doing. Influence, we can influence because of the future of influence. I think our humans mind is just like quantum computer, and so I think the logic of our human thinking is like a quantum process. So if we can build the quantum computer, I think it can have more magic field that we can explore and discover the myth of human's mind, and may discover something new that classic computer. Maybe I hope the machine QB quantum machine learning could make the AI to be the more intelligent than human. I I hope, or I would rather, I don't know. There are four fields about the quantum technology: computing, simulation, communication, intelligent, metaphysics, imaging. Computer means doing the mathematical works, and simulation means that we can simulate the on complex materials, communication, and internet means that quantum crypto and staging means that the sensor, new sensors, and so. Okay, the markets, I think there are different computing, metrics, and so on. And computing means quantum simulators, annihilators, noisy intermitters, and scale computing, universal quantum computers, and so on. And quantum communication, so quantum emulation simulators, there are different annihilators, and these are just something I share with you, and we can maybe one day we can talk with each other to explore something, and now I just think too huge resources for me, so I just ignore about them, and yeah, also for categories, general purpose, universe, computer, special purpose means the annihilators. Universe means that we can this is the ultimate goal, and with the universal computer, quantum computer with fault-tolerant millions of errors corrected physically, resulting in raw solid logic. You could run quantum algorithms in critical circuit optimization, quantum systems simulation, and linear equations solver. New algorithm, new probability. And there are some predictions that you can be fully overcome far away from never to somewhere, but from now on. And I hope that less than 10 years, I hope I can learn about I can get one quantum quantum computer and do something new. There are some comparison between today's only the very interesting the um, the binary operation is very classic, and the requirement in 24 years ago, David defines the list 5 key character must be scored for it must possible to initialize the qubits. Good qubits are needed. They must be scalable and initialize the qubits, and we have good qubits, and we have maybe we need we can have some universal set of quantum gates, and also we can or, be able to measure the qubits. Thank you very much. This is a very brief introduction. Uh, I hope I hope for nothing. Thank you very much.